Now we are going to show the simulation on the source code which is downloaded from GitHub, and now certain changes are made into that, and we have some kind of custom build. So right now I'm going to run the SUMO GUI. So it is listening on port 999, and now I'm opening my OMNET++. So it works relatively fast. The virtual machine I have is of OMNET++ 6 version, 5 version, but now on my local machine it is the latest version 6. You can see it will not take much time on my local machine in comparison to the virtual machine. So here is my veins folder again, and I'm going to run it. Veins, example veins, omnet pp.ini. So here let me check at what time I have configured the accident. So right now the accident time is configured at 73rd second. So let's reduce it to, like, say 63rd second. We can manage it. And the accident duration in initial case was 50 seconds, so I have make it at 30. And I have also reduced the number of vehicles, which were in original simulation was 195 or 96. So in this simulation I have reduced the number of vehicle to 6 using erlanggen.rou.xml. So now, since I have modified some of the configurations, so I need to build a project again. So it will build immediately, and now I'm going to run my simulation. So in my present simulation, uh, it is configured as such that, like, the vehicle will send one rogue vehicle will send a message to the RSU that an accident has happened, and right now the RSU is able to read that message and populate this message in the log form that yes, accident message has been received by the vehicle. In the current OMNET++ and this vein simulation, the RSU is not configured to receive the BSM messages from uh, vehicle. So we need to work on that, and I will also explain what we need to do in future for that. So let's start the simulation. The SUMO, this is running in the background GUI, and you can see the lots of messages are being transferred. So this is our RSU, and in this simulation I have also provided a feature of stop and go kind of thing. You can see the vehicles are not moving continuously, as they are running and then stopping. So it's some kind of beacon kind of message is there, which I am just sending for experiment purpose. So accident has happened at 63 seconds. You can see the location has changed. It was earlier ahead. So let's reduce the speed to see the message communication. You can see there. So this airframe 11p packet is very important in this simulation, because this is the packet which is carrying almost most of the messages. You can see the communication is being happening between the devices and the node vehicle and the RSU. So I'm making it fast. So now the communication is the simulation is running at a faster pace. There are certain logs I have put in the code so that I can know which message is being received, which is being sent, and how to ensure that yes, the vehicle has received some kind of accident message or not. Let's first complete the simulation. Now accident has resolved, and you can see the time is only 94 seconds. Now the vehicles are moving. They are again moving in the stop and go situation kind of thing. So I'm stopping the simulation here, and I will explain the logs after that. The simulation has come to an end, so let's explain the log. This is the demo safety message which is being sent by the RSU as a kind of to simulate the stop and go kind of situation. It is helpful when there is some kind of congestion on the road, or there is some possible accident scenarios there, so drive cautiously. So I am simulating that kind of situation. So let's see whether the RSU is able to uh, get the message from the vehicle or not. So you can see when the accident situation is there, so other vehicle also receives change route messages. This message tells the vehicles to evaluate whether changing route is beneficial or forwarding going on the same route is beneficial. So in the third simulation I will show when I reduce the accident time, so vehicle will move their you will take U-turn as well. So let's see here. So this is the base frame message, that is I think it's a 11p, some kind of name is there. So this is user priority, and right now as I said that it is not configured to receive the BSM kind of messages by car to RSU. So I am taking this user priority parameter, which is by default set to 7 to 3, and I will receive this at the RSU level. So this user priority is 3. I am just populating it here at the RSU level. This is at the car level, and this is at the RSU level. So RSU is populating the message that it has received accident message with user priority 3. So our next goal is to find out the Droog vehicle and eliminate from the network, which is the next task. So now let's see the existing arrangement. I have gone to the source code in the source veins modules application IEEE 802.11p. So it's a DSRC protocol. It is using DSRC protocol, not for vehicle to vehicle communication. So this is the header file. You can see there are two messages: send beacon event and send WSA event. uh, so for our future purpose to have a full kind of simulation, we need to add different messages in this category, and for that we need to change this NAD file, which has like all the basics, what the message is going to be exchanged and everything. So when we change this dot header file uh, and dot cc file will be changed, and then vehicles will be able to communicate with each other with custom messages. I have changed my veins.cc file to have some kind of stop and go situation. You can see I added this code to simulate this. In the next video I will show how to force the vehicles to make U-turn.